I'm on tour in Australia.
Some of them might recollapse in a fraction of a second. Others might be blown apart by loads of dark energy.
Talking about the life of our universe to scientists and to space-loving audiences.
I just like having my brain stretched.
Look, I'll probably just stop and have a look at the stars on the way home.
On our journey so far, we've explored how our universe began.
So this is the oldest light in the universe.
But what about our future?
Is there an end of the universe? Is our universe eternal?
The universe literally tears itself apart.
There is some true vacuum somewhere. We could tunnel into it at any moment.
Does it make any sense to talk about this universe in 100 billion, 200 billion, a trillion years' time? Will there be stars and galaxies, and people and questions and astronomers and televisions? What is the fate of the universe? How will it all end? I suppose we all get used to the idea that we live finite lives. Perhaps that's because we imagine we can leave a legacy, our children, grandchildren, great works. But will that legacy be eternal? Can we imagine taking the great achievements of our civilization and chiseling them into granite and leaving them as a record into the far future? Or do the laws of nature conspire to make that impossible? Will all trace of our civilization one day vanish? What will be our fate? And what is the ultimate fate of the universe?
I'm going to investigate the theories that cosmologists have put forward for the end of days.
There is a law of physics called the second law of thermodynamics. And to paraphrase it, it means that on a global scale, so across the universe, things can only get worse. So things tend to get more disordered, things tend to decay away. I was once involved in putting forward the opposite proposition, things can only get better. But that is a gross violation of the second law of thermodynamics and really shouldn't have been allowed even in a song lyric. I think, actually, songwriters should pay more attention to fundamental physics.
The first stars in our universe began to shine around 100 million years after the Big Bang. But it was another 9 billion years before our star, the Sun, formed. But our Sun won't live forever, which will obviously have a direct impact on all life on Earth.
The Sun is about halfway through the phase where it's burning hydrogen. It's making helium. It's got what we call the solar luminosity. It's putting out that much heat and light, but that is going to be slowly increasing.
Presumably, at some point, we would find it extremely uncomfortable here.
In about 1.1 billion years, it will have got to 10% brighter than it is now. That is enough to create what's called a moist greenhouse. So life on Earth will become very problematic at that stage. 3.5 billion years from now, it'll be 1.4 times its current luminosity. And that's enough to evaporate the oceans.
Right.
So that's getting fairly severe at that stage. It's really got another 5 billion years to go that it can keep on burning hydrogen, but it will become uncomfortable for us well before that.
The destiny of stars like our sun is to run out of fuel and collapse.
The core compresses, but the rest of the star expands enormously, and we have a red giant. So we enter this red giant phase.
When our sun becomes a red giant and it begins to swell and engulf the orbit of Mercury, it's going to start getting very hot on Earth. We're going to need ways to terraform Mars and then ship billions of people to Mars, because Mars will be cooler than Earth, it being 1.5 times farther away.
The Earth will basically get fried at that point. We won't be able to exist, hopefully, if humans are still around in some form or another. We've moved off to better locales.
So the ultimate fate of our star, the sun, is to be this cooling ember.
That's the ultimate fate of the sun.
So, in just over 1 billion years, this place will become uninhabitable. In 6 or 7 billion years, the sun will be gone. But that, of course, isn't the end for the universe. The matter that floats out from our dying sun will recollapse into other stars, other planets, and perhaps other living things. But that process can't go on forever. There comes a point in the life of the universe when the constant recycling, the births of new stars, has to stop.
So what is the fate of the universe? How will it all end? Cosmologists have thought about this for a long time, and many have come to the conclusion that the end will come in more of a whimper than a bang. It's known as the heat death, and it begins with a decrease in the rate of star formation. Looking up into the southern sky allows us to see a hint of this process.
As soon as you look through, you do get a sense of the amount of gas and stuff out there, don't you? You always hear this wonderful phrase, stellar nurseries. So is that really accurate, that you really do have these places where all the action is concentrated?
Absolutely. In order to form stars, you have to put together a lot of material, and so you naturally pop off a lot of stars in that particular area.
I can't start looking at it.
Fortunately, we have very powerful telescopes to see all the way across the galaxy so that we can pick out stars in all kinds of stages of their formation process, from when they just start collapsing to when they really kick on and turn into full-blown stars.
Stars form from collapsing clouds of gas and dust, and the leftover material forms into planets and moons and asteroids and comets. But in our part of the Milky Way, this construction process is slowing down. Is this a glimpse of the beginning of the end?
We see that around the sort of solar neighborhood, around where the sun lives, that there's about half as much star formation as there was 10 billion years ago.
Why is that?
Once you form a star, it dies, and it holds some of its matter together in a black hole or a white dwarf or a neutron star. And you've locked that gas up forever, and it never goes back to being a star again. So in order to keep forming stars, you've got to keep bringing gas in from somewhere else.
So the fact that the rate is dropping, so you said a factor of 2 from the, 10 billion years ago to now,
Yep.
implies, of course, that sometime in the future that's going to stop. So when is that?
It's a long time, not during our lifetimes. I think if you do the extrapolation, you go out 100 billion years or some more than that. It's a long time away. And eventually, we will run out of gas to form new stars in every single galaxy. And gradually, 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 the universe will die away.
So what will our descendants actually see when they look up into the night sky in a few billion years' time?
Where are we? The center of the galaxy is here, isn't it? Straight above our
Yeah, it's
heads.
kind of the empty bit of sky up here. Sagittarius.
Peer into the center of the Milky Way, And like virtually all other galaxies, you'll find a supermassive black hole. Ours is around 4 million times the mass of the Sun. We don't know how these supermassive black holes form, but we do know about smaller stellar mass black holes.
And when the center of those stars are more massive than about 2 or 3 times the mass of our Sun, they actually collapse into a singularity, is the theory. And the space-time around them bends completely on itself. So nothing, the gravitational pull is so strong, nothing, even light, can't escape.
So then we're left, I suppose, with a dark sky, but a sky full of black holes.
Yeah.
And what, fading stellar remnants?
Yeah, fading stellar remnants, things like faintly glowing cores of long dead stars, billions or even trillions of years in the future. And these are glowing so faintly you can't even see them. Now, black holes do radiate very, very faintly, but we won't actually be able to see that because they'll all be too far apart.
You get the sense, I suppose, when you talk about that, this starry sky we take for granted, although perhaps we don't, perhaps the most beautiful thing, but it's a temporary phenomenon.
It's actually a very short-term phenomenon, isn't it? We're only nearly 14 billion years into the universe's history.
So in the far, far future, hundreds of billions of years' time, we could still stand somewhere and look out into the night sky, we would see just blackness. And there would be no hints at all to tell us about the past glorious history of our universe.
But is this the whole picture? Science has a habit of opening up new possibilities, often when you least expect them. We've known our universe is expanding since the 1920s, and we thought the expansion rate was slowing down. Then, in the late 1990s, it was discovered that the expansion rate of our universe is actually speeding up. Nobel Prize winner Brian was as surprised as anyone by his discovery.
1998, we went through and we measured that the universe wasn't slowing down at all. It was speeding up. And that was, well, it looked to me like a big mistake and that I had somehow wasted 3.5 years of my life getting some nonsensical answer. We knew that Einstein had invented something called dark energy or the cosmological constant, which makes gravity push rather than pull, but that seemed pretty crazy. That was sort of Einstein's bad idea.
If the universe continues to expand forever, and indeed continues to accelerate in its expansion, then in the far future, you end up with a universe that's just a sea of photons being stretched by the expansion of space, cooling down to the same temperature. So you end up with a universe where there is no structure, there's no possibility of storing any information or processing any information, no possibility of consciousness or life, no structures at all, and that sea of cooling photons will last forever.
The idea that there is a mysterious thing called dark energy which drives the accelerating expansion of our universe forever is the standard model of cosmology. But it's not the only theory about how our universe could end.
The heat death, this idea the universe just gradually grinds to a halt and carries on expanding forever, is a bit miserable. But the physics of the far future is not very well understood. So there are, in fact, other, I think, more exciting possibilities.
So, like the Robert Frost poem, it seems like things will end in ice, not in fire. But there's a big caution here, which is we don't really understand dark energy very well. And so this is really only one of a couple of possibilities.
Cosmologists have come up with an even more devastating idea called phantom dark energy, which eventually leads to the universe ripping itself apart.
If the universe has this dark energy, this stuff causes gravity to push from itself.
This is another really great way to destroy the universe.
So as the universe gets bigger, this stuff dominates the universe more and more because it's part of space itself. You make more space, you have more dark energy, which makes dark energy stronger over the other forms of gravity.
Over time, this phantom dark energy would start to pull apart bound orbits. So first it would pull apart the galaxy, stars would start to wander off because it's still increasing. It'll start to break up all structure, all matter. And then at some point, the entire universe will be torn asunder in some sense. It's called the Big Rip.
You reach the breaking point, literally, and the fabric of the universe starts to tear a hole. The laws of the universe and the boundaries of the universe just start going haywire.
So that's the Big Rip.
So that's a Big Rip. I mean, that's one of the theories, right? There's the Big Rip and the Big Freeze. I love the Big Rip because who doesn't like a universe ripping, right?
The Big Rip idea can be combined with a theory we have describing the beginning of our universe, known as inflation, which describes a time before the hot Big Bang, when our universe was expanding extremely rapidly.
So inflation,
that's right.
That rapid expansion before the Big Bang could be envisaged as being the end of a previous universe that's undergoing a big rip.
Exactly. It's, you know, you have these big questions, but when you look at it fundamentally, if you have a universe that grows quickly through dark energy, which rips, that would mimic pretty similar to what we think it happened in inflation. And we are pretty confident we know inflation had to happen in some form to get the universe that we see today. So it's not crazy to think that these two things are related. We don't have the evidence for it yet, but it's not the worst idea we've had.
We said that inflation stops and the Big Bang happens. But what if inflation doesn't stop all at once? It just stops in patches. So then our Big Bang would just be a little event in an ever-inflating space. And there'll be other patches that stop and you get a universe. Other patches that stop and you get a universe. And that process could go on forever. So although our universe dies, other universes are constantly being created. This is called the inflationary multiverse.
So you get this wonderful process of Big Bang after Big Bang after Big Bang, yielding universe after universe after universe.
How are you to picture that? How are you to picture our universe riding on the back of some kind of potentiality of expanding space-time?
You can. I've got a more down-to-earth way, which is think of a big piece of Swiss cheese, big block of Swiss cheese, right? Each of the openings is like a universe. And the cheese itself is the inflaton field driving the ever-accelerated expansion of the universe. And as this cheese expands, more and more pockets open up inside, more and more universes are created. And our universe is simply one opening in the block of Swiss cheese. That's all that we are.
The idea of a multiverse is tricky to get your head around.
This is where we keep cream of the crop.
But I'm hoping a glass of Aussie Shiraz will enhance my powers of analogy.
Cheers, thank you. I'm tempted to draw the analogy with inflationary cosmology and say that each one of these is like a different universe with different physical laws. Each barrel in this warehouse is taken from a different part of the vineyard, so each barrel is a different expression through the grapes of the landscape. So in that analogy, our universe would be just one barrel of Shiraz Viognier, in this case, amongst a whole possible warehouse of barrels, different expressions of possibilities. It's a good analogy, not too forced. Physicists refer to each different possibility as a different vacuum.
And this opens up the chance that we could be instantly annihilated.
My favorite way to destroy the universe is vacuum decay, which is a really fun idea and one that's gotten really popular lately because of things that we're seeing at the Large Hadron Collider.
The Large Hadron Collider at CERN on the French-Swiss border is the largest scientific machine in the world. In 2012, the Higgs boson was discovered here. But its properties suggest that our universe could be in an unstable, false vacuum state.
There is some true vacuum somewhere, and we could maybe tunnel into it at any moment and just destroy
But by
the
any
universe.
moment, you probably...
I mean, it's unlikely.
You're a cosmologist.
Yeah.
If you're still watching this, it hasn't happened yet.
The timescale for vacuum decay is many times the age of our universe, so it's not going to happen tomorrow. But it's still disconcerting to think that our universe isn't the stable, eternal home we once believed it to be.
But you might think, well, quantum mechanics, could it save us? Could there be a little fluctuation that allows something to happen and reboot part or all of the universe? You know, you never know, but probably not.
Whether it's vacuum decay, a big rip, or a sad, slow heat death over the next 10 to the 1,000 years, now is the time to explore our universe while it's still visible to us.
We live in a special time in the universe's history. Actually, the time when the universe is young enough that we can look out into the night sky and see billions of galaxies. The galaxies are not receding away from us fast enough that they outrun the light.
So our descendants, when they look out into deep space, will see black, inky, dark stillness. And they'll think that this little collection of galaxies that are all bound together gravitationally nearby, they'll think that's it. And that's a wrong picture of the universe, but nevertheless, that's the picture which our descendants are going to naturally be led to through their own observations.
The future astronomers in 2 and 4 and 6 billion years will think we're crazy because they can't see the evidence that we have.
I think actually it was Brian who said to us that cosmology essentially becomes a religion.
That's right, yeah.
Because all you've got is history books telling you
exactly
about the oldest light in the universe.
That's right, but you can't go and reproduce the experiment. We would just have to believe someone else's word, and then what are we doing?
Who are we to think, who are we to say that we have a complete record of the universe to draw from? What chapters of our book of the universe have been removed before we even acquired the book?
The fascinating thing about the far future in an accelerating, expanding universe is that you get to a point where you can't do cosmology anymore. There's no such science as cosmology. You couldn't deduce from what you see that you live in an expanding universe that had an origin at some point in the past. So cosmology becomes a subject that is only accessible through ancient books and not accessible through the things you can see. So in that sense, I think that the future of the universe is sad because your ability to gather knowledge about the universe as it was in its past disappears.
How will the universe end?
I have no idea.
I don't know.
I don't know.
You know, it's very difficult to make predictions about the fate of the universe when there's 95% we don't understand.
We should just make a documentary called I Don't Know.
Galaxies are forming and stars are exploding and you know, we're seeing evidence of things happening in the Big Bang and the universe is expanding ever faster. And we're just sitting here drinking our tea.
Yeah.
I've had the good fortune to share my enthusiasm for physics and the cosmos with Australian audiences curious to contemplate the nature of our universe.
Amazing. Absolutely tremendous, yeah.
Oh, he takes us on a great journey, I think.
Did you understand it all?
Not all of it, but yeah, bits and pieces of it, yes.
I love the fact that when I finish work after a really hard day, I can come to something like this and he can make me feel really insignificant compared to the rest of the universe.
And I've met scientists under a truly inspiring southern night sky who share that curiosity and desire to know more.
We got work to do.
I suppose there are two ways of looking at the future of the universe. You might feel depressed that although the universe will almost certainly exist forever, we certainly won't. There will come a time in the future when it's not possible for any life to exist. Or you might feel fortunate. You might feel fortunate that we live in a time when we can look out into the night sky and see the light from distant stars and galaxies, and from the very origin of time itself, and understand how our universe began and make predictions about how it might end.
From April 4 to April 6, I'll be in Australia, and together we can marvel at the wonders of the universe.
Join Professor Brian Cox and Julia Zamiro for Stargazing Live. Starts April 4th at 8:30 on ABC and iView.